Hi, in this video, we'll be looking at the distributive property. This video is part of the series binary operation that we started 4 videos ago. We started by talking about binary operation, then we moved on to talking about the closure property, we moved on to talk about the commutative property, and the last video we talked about the associative property. So if you've not watched those videos, you can do well to catch yourself up to speed with that before coming to watch this video on distributive property of binary operation. So what does distributive property actually mean, or what does it entail? So we are told that if star and delta are defined over real numbers in such a way that A star B delta C is equal to A star B delta A star C. For all members of A, B, C being elements of the real numbers that the star and delta have been defined over, then we can now say that the operation star is distributive over delta. I'll come again. It says if star and delta have been defined over a set R of real numbers. What are real numbers? Numbers from negative infinity to positive infinity. That is whole numbers. Minus 1 billion is a real number. Plus 2 billion is also a real number. So when we have star and delta, and then they have been defined over set R, like set of real numbers, in such a way that by the time we combine them together, A star B delta C, if you combine A star B delta C and then we decide to take it in another order in such a way that we now say A star B delta A star C, for all members A, B, C being elements of real numbers, then we can now come to a conclusion and say the operation star is distributive over delta. Now, what does this mean? Let's try and look at a demonstration. So let's say, for instance, we have okay, so let's start with this. So let's say we have 5 times 3 plus 2. Now, for this to be distributive or for multiplication, this first symbol you can see here, we have star. So let's assume our star is our multiplication and then our delta is addition. For us to confidently say that multiplication is distributive over addition, then it means if we combine this in another way, in such a way that we have 5 times 3 then plus 5 times 2. If these two are equal, then we can come to a conclusion and say multiplication is distributive over addition for real numbers. So let's try and solve and see what we're having. So again, we start with the one in brackets. 3 plus 2 gives us 5, and 5 times 5 gives us 25. So let's see whether we have the same expression on this side. 5 times 3, this is 15, plus 5 times 2, this is 10. By the time we have 15 plus 10, so this gives us 25. So you can see that 25 equal to 25. So what's the conclusion we can come to? We can say that multiplication is distributive over addition for sets of real numbers. Like this, all the numbers has to be real, not complex numbers. All right, so let's see let's see another demonstration. Let's see whether multiplication is actually distributive over subtraction. So, and then we can come to another conclusion whether or not multiplication is distributive over subtraction, or it is not distributive over subtraction. So let's try and see. So this time around, let's say we have 4 times 5 minus 2. Of course, we know for this to be distributive, it must mean that I can take 4 times 5, then again minus 4 times 2. So if these two are equal, then definitely we can say that multiplication is also distributive over subtraction. So let's try and look at this. Let's solve the left hand side. So 5 minus 2 gives us 3 times 4, and 4 times 3 gives us 12. So let's see the expression on the right hand side and see whether we have at the same thing. So 4 times 5 gives us 20, minus 4 times 2 gives us 8. So and then 20 minus 8 again gives us 12. So what can we say? 12 equal 12. So definitely we can also say for all set of real numbers, multiplication is distributive over subtraction. So multiplication is distributive over subtraction. So let's try and flip it the other way around and see whether the same will still hold true. So we'll try to see whether it's so we're given our first example, but this time around, I switched the sign. You know, in the former example, we did 5 times and 3 plus 2. But this time around, we want to see whether addition is distributive over multiplication for the set of real numbers. Now, for this to be distributive, then it must mean that 5 plus 3, then in brackets, times 5 plus 2. So these two guys must be equal. That is, the expression on the left hand side must be equal to the expression on the right hand side. So let's try and see whether this gives us the same thing. Of course, we start with the one in the brackets and then with the expression on the left hand side. So we have 5 plus 3 times 2 is 6. So 5 plus 6 gives us 11. Okay, so let's see the expression on this side. So 5 plus 3, so this is 8. And then multiply by 5 times 5 plus 2 is 7. And 8 times 7 gives us 56. So we have 56. You can see 11 is not equal to 56. So we can come to a conclusion that addition is not distributive over multiplication for the set of real numbers. For the set of real numbers, addition is not distributive over multiplication. Also, subtraction is not distributive over multiplication. Just I will have demonstrated it here, but just not to make the video extremely lengthy. So that also is valid. So subtraction is not distributive over multiplication, but multiplication is distributive over addition, and also multiplication is also distributive over addition. So that's those ones are valid. All right, so let's look at a more refined example, and then we can look at our next property in subsequent videos. So we are told that the operation star is defined by A star B equal to 0.5 AB. If A equals to 4, B equals 7, and C equals 10, we're asked to evaluate Roman figure 1, A star B plus C, Roman figure 2, A star B plus A star C. Then Roman figure 3, what conclusion can you draw about star from your answers in 1 and 2? All right, for this question, you have to be careful because the only operation that is being defined there is the operation star. For the other operator we're using here, this is a basic operator. So when we see addition, we know what it means. We're just adding. So this is not, because this is also a binary operator, but it doesn't have to be defined, or it won't be defined for us rather. So what we want to do is to evaluate Roman figure 1. So let's start with that anyway. So Roman figure 1, so we have A star B plus C. Now what is my B? So this becomes A star. So my B, okay, so let me write it in place of the numbers. So A is equal to 4, so there's no point writing A again, so let's just write the number. So 4 star. Then what is my B? My B is 7 plus what is my C? My C is 10. Okay, so this becomes 4 star, so 7 plus 10, that's 17. So this one, this operation star is defined as 0.5 AB. So again, now this time around, we're not going to use the A in the question. That is, A is already 4, no, and B is 7. Of course, here A is still 4, so that's just a coincidence. But B, instead of B being 7, we have to use 17 now because you can see A star B, this is 4 star 17. So this looks like A star B. So you want to avoid errors in that regard. Okay, so what do? A is 4, B is 17. So we have 4. Okay, so let me not write this. So let me just write 0.5, okay, times 4 times 17. So this is what has been defined there. I don't want to repeat it twice. So I hope you are following. All right, so multiplying this, 0.5 times 4, that's 2, and 2 times 17 is 34. So this is simply equal to 34. So the first part, A star B plus C is equal to 34. Again, let's just repeat what we've done. Uh, we said from the question A is equal to 4, B is equal to 7, C is equal to 10. And then we wrote it like this. But we have to be careful because only the operation star is defined or have to be defined. For addition, we know what it means to add. So 7 plus 10, add them directly. And then when we now have 4 star 17, so we assume this is A and then this is B. And then we come to what has been defined here for us and then just multiply. 0.5 times 4, that gives us 2. Same thing as saying 1 over 2 times 4. So that's 2, and 2 times 17 is equal to 34. All right, so for the second part of the question, so here we have A star B, A star B, okay, plus A star C. Now for this one, because we don't have any numbers, the only thing we have is A star B. So unlike this where we had 4 star 17. So for this, we have to go back to the original question. What A is, what B is, and what C is. So I hope this makes perfect sense. Okay, so what is my A? A is 4. So this becomes 4 star 7 plus again 4 star 10. So sub them separately in the brackets. So this becomes anywhere we say star, the operation star, this is what has been defined for us. So what do? We just come here and we say 4 star 7. So that will be 0.5 times 4 times 7. So 0.5 times A times B. Okay. So plus, so this time around 4 becomes my A and 10 becomes my B. So again we say 0.5 times 4 times 10. All right, so let's look at this. 0.5 times 4, that's 2. 2 times 7, that's 14. Plus 0.5 times 4, again, that's 2. 2 times 10, that's 20. And then 20 plus 14 gives us a total of 34. So you can see that when we did the first evaluation, A star, B plus C, we're having 34. And then for the second part also, we're still having 34. So moving on to the third part of the question, what conclusion can be drawn from star from our answers in 1 and 2? So since we're having the same answer, then it can be said that the operation star is distributive over the operation addition. So the operation star is distributive over the operation addition. I hope this makes sense. So let's try and look at one more example before calling it a day on distributive property. So for the next example, we're told that the operation star is defined on the set P equal to 4, 6, 8, 10 by A star B equal to 0.5 A minus B. For the option A, we're told that if A equals to 9, B equals to 5, C equals to 3, evaluate A star B plus C, Roman figure 2, A star B plus A star C. And option B, we're asked what conclusion can be drawn from star from our answers in 1 and 2. All right, now the conclusions we want to draw, you can say that from the starting point, we can note that only one operation is defined, that is star. The other operator we have here, addition, we already know what to do. So anywhere we see addition, is simply to add the numbers together. Now, secondly, we are given the set P. So the members of set P, 4, 6, 8, and 10. Now, some questions. What's it called? Set P will contain will contain the values of A, B, and C. You can see for set P we have 4, 6, 8, and 10. But the value of A is 9, value of B is 5, value of C is 3. So peradventure we can find 9, 5, and 3 inside of set P, And after applying this rule, our results, so this first evaluation, this second evaluation, after applying the rule, if the results can also be found inside of this set P itself, then we can come to two conclusions. First one, whether the operation star is distributive over addition, and second one, whether it is closed. So remember, we'll talk about closure property in our first video. All right, so let's start solving. So Roman figure 1, so we are asked to evaluate A star B plus C. So A star B plus C. Okay, so trying to evaluate this, A is equal to 9, so 9 star, my B is equal to 5, plus C is equal to 3. So treat the one in the bracket first. So treating the one in the bracket first, we have 5 plus 3 gives us 8, and then 9 star 8. Now when we see star, how do we define star? A star B is equal to 0.5 in the bracket of A minus B. So this will be the same thing as saying 0.5. So let me write that properly. So 0.5, okay, open bracket. So my A is 9, and then my B is 8. So 9 minus 8. So 9 minus 8 gives us 1, and 1 times 0.5 is simply 0.5. So we have 0.5 here. That's for the first part. For the first part, we're having 0.5. Again, let me repeat myself. A is 9, B is 5, C is 3. So add 5 and 3 together, we have 8. And 9 star 8, come to use this operation, 0.5 in the bracket of A minus B. My A is 9, my B is 8. So 9 minus 8, that's 1. And 1 times 0.5 gives us 0.5. All right, so for the Roman figure 2 parts, so we're asked to evaluate A star B plus A star C. So what is A star B? So again, my A is 9, so I have 9 star 5 plus, again, 9 star 3. Okay, so doing the same thing, 9 star 5, what do 9 star 5 give me? Coming to use this rule, so I simply have 0.5, can open the bracket again, so this becomes 9 minus 5, okay, and then close your brackets, then plus again 0.5 in the bracket of, again, 9 minus 3, and close this brackets. Okay, so 9 minus 5 is 4, so we have 0.5 in the bracket of 4 plus 0.5. 9 minus 3 is 6, so closes brackets. 0.5 times 4, so that gives us 2, and 0.5 times 6 gives us 3. So 2 plus 3, we're having 5. So you can see that when we evaluated the first set of questions, that is A star B plus C, our answer or our result is 0.5. 0.5 can be found in set P, but that's not a problem since none of A, B, and C can also be found in set P. But what we're saying is if A, B, and C are members of set P, and also the result I'm having here, 0.5 and 5, if they're all members of set P, then the first conclusion we can draw is that the operation star is closed underneath this rule. So, but since none of that is there, so we can discard that one. Now, the second conclusion we can draw is whether the operation star is distributive over the operation addition. So you can see that 0.5 is not equal to 5. So definitely, our conclusion that can be drawn from B is that the operation star is not distributive over the operation addition. So the operation star is not distributive over the operation addition. Let us look at one more example. So where we are given two operations that will be defined. Consider the last examples we've been doing. We're only defining one operation, and then we're given another basic operator. So let's see what happens or how we solve questions when we're given two binary operations that will be defined. All right, so for our last example, underneath the distributive property, we are told that two operations, star and delta, are defined over the set R of real numbers by a star b equal to a minus 2b, and a delta b is equal to a plus b minus ab. We are asked to calculate the value of Roman figure 1, 5 star 7 delta 3, and Roman figure 2, 5 star 7 delta 5 star 3. In the last part of the question, we're asked what conclusion can be drawn from the answers we are having above. So, how is this different from the previous example? You can say for the previous examples, we're only defining one operation and then we're using another known operator. So, but this time around, we're giving two operations that has been defined. So you can say we've defined A star B, what A star B is, and then we've defined A delta B, what delta B is. All right, so let's take our first part. So for the first one, we're having 5 star. So this time around, we'll just solve directly inside of the parentheses. So when we see delta, so A delta B, we're asked to simplify using A plus B minus AB. Of course, 7 becomes my A and 3 becomes my B. So what do I write? I write 7 plus 3 minus 7 times 3 and close my bracket. So this is the first one. And then I have 5 star. So let me trace the value I have inside of the bracket. So 7 times 3 gives us 31, 21, and there's a negative sign in front. So this becomes 7 plus 3 is 10. So 10 minus 21. And 10 minus 21, so that will roughly be 11. So I have 5 star 11. Now, since I have what's it called, star now, I have to use the other operation that's defined as a minus 2b. So definitely 5 becomes my new a and b is 11. So this will be equal to, so this is 5 because anywhere I see a star b, I should treat it using a minus 2b. So that's 5 minus 2 in the bracket of 11. And 2 times 11, so that gives me 22. And 5 minus 22 will simply be minus 17. So we're done with the first part. We're done with the first part. So let's try and see the second part of the question so we can come to a conclusion on what it means or what we've done. Now for the second part, we are going to split them. That is 5 star 7 delta 5 star 3. So again, let's just do that inside of the bracket to conserve space. So 5 star 7, anywhere we see star, this is the operation that is defined for it. So my A here is 5, my B here is 7. So I write 5 minus 2 in the bracket of 7. Okay, do my delta again, 5 minus 2 in the bracket of 3. So this is what I have. Now 2 times 7, that's 14. So here I have 5 minus 14. Okay, delta 2 times 3, that's 6. So here I have 5 minus 6. All right, now 5 minus 14, so that gives me minus 9. Delta 5 minus 6 gives me minus 1. Okay, so now I can now use my operation or operator, operation delta. So where we have a delta b, we want to do a plus b minus a b. All right, so now my a becomes minus 9 and then my b will be minus 1. So this is where is it, minus 9. Okay, so plus minus 1, which negates this equation or this expression rather. But let's still move on. Then minus again, this is minus 9 times minus 1. Okay, all right. So now I've written this. So minus 9 plus minus 1 is simply as saying minus 9 minus 1. So this is minus 10. Then there's a minus sign here. Minus 9 times minus 1 is plus 9. So plus 9 times this negative side again, so becomes 9. And minus 10 minus 9, so this just gives us minus 19. Okay, so now for the B part of the question, what conclusions can be drawn from your answers above? So when we treated the first question, the first evaluation, we had minus 17. And for the second one, we're having minus 19. So since 5 star 7 delta 3 is not equal to 5 star 7 delta 5 star 3, then we can come to a conclusion and say that the operation star is not distributive over the operation delta. The operation star is not distributive over the operation delta. So I hope this makes sense. This is all I have for you underneath the distributive property. So if there's any question that you'd like us to go over or solve, you can do well to put such question in the description box. And also try as much as possible to share this video to your friends that will need them, your siblings that are preparing for JAM, WAEC, or NECO. See you in the next video. Thank you. And